Hello, is my voice audible and if my video is visible? Okay, so is the presentation visible? Okay, okay, so we will wait and let others join. Okay, so good evening to the students who have joined. We will wait for 2 to 3 minutes, then we will start today's session. And I hope my voice is clear and the screen is visible. If not, please let me know in the chat box. Yeah, good evening. Okay, so very good evening to the students who have joined the class till now. My name is Moshumi Dev and I am a PMRF fellow from the Department of Chemistry and Chemical Biology, IIT ISM Dhanbad. It is the NPTEL it is a tutorial class for the NPTEL course of Medicinal Chemistry. Today is the week 2 live session, and in this live session we will discuss our week 3 course details. Whatever you have guys learned in the week 3 about the assignment problems, regarding the assignments, all we will solve today's class. So basically we will solve some 15 to 20 question in every class each week regarding that week's course structure, and today it is for the week 3 course materials. Okay, I think we can start our session, and as people will join, I will just add them one by one in the meeting. Okay. Or we will wait for 2 to 3 minutes more to see if other people join. Okay, so one more thing, during the lecture, at any if in any question and any part you have any doubt, so basically please write in the chat box. Okay, so the chat box is always open for you to raise your queries about the materials or about the questions which we will solve today and about everything. So if you have any question, any doubt, so you guys can easily reach out through the uh, chat box. Okay, and at the end of the session I will answer all the queries which have been raised in the chat box. Okay, so we will start just today's session. Okay, so the previous sessions slides and videos, everything, I think it will be communicated to you by the side of the NPTEL. Okay, so in the NPTEL website I think you will find regarding the previous years, I mean the previous session videos and slides. So we all actually send it to the NPTEL, and they actually upload it in their website. So in the SWAM website you can check it, and I think it will be available to you in that website. So last week we did the tutorial class for our week 1 and week 2 lecture materials, and this week we will do it for the week 3 lecture material. Okay, and at any question, any point, if you don't understand anything or have any query, you write in the chat box. At the end of the question I will take those queries. Okay, and anyway at the end of the session I will share my email ID also. So if you have any query regarding anything about the class, about the course, you can just connect me through the email. So I think we will just it is better if we start the session. Okay, so the first question, it says that where does inhibitor binds on enzyme in a mixed inhibition, and the options are: number A, allosteric site; option B, active site; option C, it's bind on the substrate; and option D, it does not bind on the enzyme. So in this question it has been asked that where does the inhibitor molecule binds on enzyme in a mixed inhibition. Okay, so anybody wants to answer that question? You can always answer the questions in the chat box. Okay, I will show you the answer then first. So the answer will be allosteric site. Now what is the allosteric site and what is an active site? So basically an allosteric site is a region of an enzyme where the activator or inhibitor molecule can bind and either activate or decrease the enzyme activity. Okay, so the allosteric site is a region different for every enzyme. So there is a enzyme, an active site of an enzyme is an area where the substrate molecule binds and the enzyme catalyzes the reaction which results in the creation of the specific product. So in every enzyme there should be an active site. In that active site the substrate molecule binds and the reaction takes place and the product molecules are released. But apart from that active site, there may be a region in the enzyme where the activator or inhibitor molecules bind and they activate or decrease the enzyme. They can activate the enzymes and they can decrease the activity also. So the allosteric sites, they are only found in allosteric enzymes, but active sites are present in all enzymes. The allosteric site, after binding the molecule, it actually works on the substrate, and for the active sites the effector molecules may act on the substrate from there, and the allosteric site they do not have two separate websites, but for the active site binding and catalytic sites are two different sites. Okay. So, what happens in case of the mixed inhibition or non-competitive inhibition, what happens, like there is an enzyme, as you can see there is an enzyme, I will just use a pointer. So, there is an enzyme molecule, okay, and this is the substrate molecule. So, this is the active site, this V shape, it is the active site of the enzyme, and there is a this is the roundish semicircular shape which is the allosteric site, and this is the your inhibitor molecule. So, what will happen? So, as the inhibitor molecule is binding to this enzyme, what happens, the structure of the active site is changing, right. It is the V shape here before binding the inhibitor, but after binding with the inhibitor the size it changes and it becomes rectangular, and because of that the substrate molecule now cannot bind to the active site of the enzyme, and the result is that the inhibitor binds to the allosteric site and no reaction happens because the active site shape is changed. Okay. Now, this is also a diagram for the mixed or non-competitive inhibition. Okay, the mixed inhibition and non-competitive, it are sometimes the two terms are exchangeable, means we can use this term for similar cases. So, this is the enzyme molecule, this is the inhibitor binding site and it is the substrate binding site, okay, and this is the inhibitor and this is the substrate. So, what happens, like it is the enzyme substrate complex. So, when the enzyme binds, once again somebody wants to join. Okay. So, what happens, when there is a inhibitor present, the inhibitor will bind to the inhibitor site, the allosteric site here, and when there will be there is the substrate present, it is bind to the enzyme substrate complex is formed. Okay. Now, what will happen? See, if there is no inhibitor present in this diagram, there is no inhibitor present, and this enzyme substrate complex, it can act easily, it can the enzyme can fold itself, and the reaction, it is a compact structure and products are formed. But in presence of inhibitor, what will happen, this enzyme cannot be closed like this, okay, and in this result what will happen, we will not get any product. Okay. So, that is the role of the inhibitor, and this is called the mixed inhibition, or the where the inhibitor binds to the allosteric site. Because of that, the active site either it changes the shape, or what can happen, like because of the binding, the enzymes, the substrate will bind, but it will not work. Okay. So, this is your, it was your mixed inhibition, and it is about the allosteric site. Okay. So, I think it is clear, and so as I said, if you have any doubt regarding any point of any question, please do write in the chat box. Okay. I will take and you can also write the answers when I show a question. You can try to solve it yourself and write the answer in the chat box. After showing you the question, I will just check if anybody has answered the question, and then we will move forward. Okay. So, I think the problem number 1, it is clear to all. Okay. Now, I will move toward our problem number 2. So, the problem number 2, it says which type of ring structure is present in structures 1 and 2. So, it is your structure number 1 and it is the structure number 2. Now, you have to identify this ring which is present in both 1 and 2 number structure. Okay. So, the options are as follows: quinoline ring, pyrimidine ring, naphthalene ring or purine ring. Now, you have to identify this ring and this ring, which is the type of these two rings. Okay. Your options are as follows: A, B, C and D: quinoline, pyrimidine, naphthalene and purine. Now, you can just try to solve this question. Do we have any answer in the chat box? Okay. So, many people have said it is the purine, number D. Okay. Let us see. Okay. So, your answer is correct, it is purine. So, this is the structure of quinoline. Okay. So, as we solve this kind of question, it will be better to know, since this course is one part of organic chemistry. So, it will be better for you if you know the names of few structures, few organic molecules, few cyclic molecules. So, it will be easier for you. Okay. So, this is your quinoline ring, this is your naphthalene ring. Okay. So, the number A and number C. So, this is the quinoline, this is the naphthalene. So, for the purine and pyrimidine, so this is the purine rings which is present in the A and D. So, basically this is the, as you know, these are the nucleobases, okay, which is present in our nucleosides like in the DNA and RNA. So, first one, it is the adenine, and the second one it is the guanine. Okay, this is the cytosine, this is the thymine, and this is the uracil. And uracil and thymine, they both are I think similar, only the methyl group is present and absent. Thymine is present in the DNA and uracil is present in the RNA. So, as we all know it. So, okay, so this bicyclic ring which has this pyrimidine kind of ring. So, when there is a 6 member ring like this, and the 6 member ring which have this if we have a 6 member ring, and in this 6 member ring if we have 2 nitrogen at 1 and 3 position like here and here, so then we call it pyrimidine. So, here you can see it is a 6 member ring, and nitrogen they are 1 and 3, 1, 2 and 3. Okay. So, they are 1, 2 and 3 to each other. So, 1, 3 position the nitrogen, this is called the pyrimidine ring. If the nitrogen is like 1 and 2 position, so there is a nitrogen here and nitrogen here side by side. Okay. So, this is called the it is pyrimidines, and this is called the I think it is called the pyrimidiles or something, and there is also called one thing called pyrazine. Okay. Pyrazine is 1, 4 position nitrogen. So, this is your pyrimidine ring, and what happened, like there is a pyrimidine ring, and side by side we have a 5 member ring where nitrogen has 1 and 3 relationship, and this 1, 3 relationship it is called the imidazole ring. So, there is a pyrimidine ring and there is a imidazole ring all together. Okay. So, it is called the purine ring. So, it is called the purine ring. So, I think this was a easy question, but sometimes it actually people get confused about all the rings and where the nitrogens are present and what is the names of the rings. So, I think it will be better if you can remember the structures of the all nucleobases, because there are many questions regarding the nucleobases and they come, and it will be better if you can remember the name of the all nucleobases. Okay. Like the names and the structures also. Okay, so I think the problem number 2 is everybody has understood the problem number 2. Then we will go to the problem number 3. Okay, so the problem number 3, it says that, so read the question carefully. Okay, the structure of DNA is closely related to its biological function. Which of the following statements regarding the structure of DNA is correct? Number A, all base pairs interact by forming 3 hydrogen bonds. Number B, DNA is comprised of nucleotide subunits each containing a base and a ribose sugar and phosphate group. Number C, the double helix of DNA is stabilized by interactions between the adjacent ribose sugar. And number D, each DNA sequence fold into a unique complex 3D structure. So, you have to identify the correct statement about the DNA. Okay. So, we have one answer till now, and it says that it is B. Okay. So, let others try. Okay. So, this was the question. So, number B says DNA comprised of the nucleotide subunits containing a base, ribose sugar and a phosphate group. Okay. Let us see. Okay, so I will show you the answer first. Okay, so number B was the correct answer. So, DNA is comprised of nucleotide subunits each containing a base, a ribose sugar and a phosphate group. So, this is the chemical structure of a DNA. Okay. So, as you can see here, so this is the chemical structure of the DNA. Okay. So, what the sugar phosphate is the backbone. So, there is a base, and the base is joined by the phosphate. Okay, and there is a sugar moiety here. So, there is a sugar, there is a base and there is a phosphate, and the sugar phosphate backbone, it holds the DNA. Okay. So, DNA is polymer made up of units called nucleotides. The nucleotides are made of 3 different components, a sugar group, a phosphate group and a base. So, there are 4 different bases like adenine, thymine, guanine and cytosine. So, this is the adenine, this is the thymine, this is the guanine and this is the cytosine. So, what holds DNA strands together? DNA strands are held together by hydrogen bond between bases of the adjacent strands. Strands. So, adenine always pairs with thymine, while guanine is always paired with cytosine, and adenine pairs with uracil in case of the RNA. So, as you can see, this is our adenine molecule, this is the thymine molecule, and adenine and thymine, they form actually 2 hydrogen bondings. Okay. between the guanine and cytosine. So, there are 3 hydrogen bondings are present. Okay. So, from DNA to proteins, the base of the single strand DNA acts as a code. Okay. The letters from the 3 letter as a codon, and which code is amino acids of binding block of the protein. So, DNA, from this DNA by the transcription we get the RNA, and from the RNA with the translation we get this protein. Okay. So, an enzyme RNA polymerase, this transcripts DNA into RNA messenger nucleoside mRNA, and then it splits apart 2 strands and take from the double helix. Then it reads the strands and copies the codes. Okay. So, we do not need to learn each and everything about the protein and the translation. We will learn about it in the later part of today's class. Okay. So, it should be deoxyribose sugar in DNA. Yeah, it should be, it is the deoxyribose sugar in the DNA. So, I think if I am not wrong. Okay, okay. So, there was a little mistake here. So, it will be deoxy. So, okay. So, this is the, I will just correct it here. Okay. So, thank you for just letting me know. So, there was a typographical error. So, it will be deoxyribose base, ribose sugar. Yeah, and ribose sugar is present in the your RNA molecule. Okay. So, I think this is, now this is fine. Okay. So, I think question number 3 is clear to all. So, do you have any other problems regarding this question number 3? Okay. Okay, how to learn DNA sequence? Okay, we will just come to these points at the later of the course and later of today's class. Okay. So, let us check. Okay. So, problem number 3, I think it is understandable by everybody. So, we will just move toward our next problem. So, problem number 4, it says that a student is conducting an experiment in which he adds an inhibitor to an enzyme catalyzed reaction. So, when the student first adds the inhibitor, the reaction rate decreases. However, he can return the reaction rate to normal by adding large quantity of substrate. What type of inhibitor is he using? And the options are as follows. Number A non-competitive inhibitor. Number B, a competitive inhibitor. Number C, an uncompetitive inhibitor. And number D, the student is likely make to a mistake. The result is unacceptable regardless of any inhibition. So, in this question, so it is a statement where a student is conducting an experiment where he has added some inhibitor to an enzyme catalyst reaction, and the when the inhibitor is added, the reaction rate decreases, but however, the normal reaction rate can be attained by adding a large quantity of the substrate. So, which kind of inhibitor the student is using, and you have to find out the correct answer. So, do we have any correct answers for this question? Okay, so some have said it is number B, some have says it is A. So, we have maximum A, B and 1 A. So, let us see. Okay, so B was correct, the competitive inhibitor. So, what happens in the competitive inhibitor? So, okay. So, in a competitive inhibitor, what happens, like this is a graph of the competitive inhibition. Okay, as you can see, so there is when there is no inhibitor present, so the reaction rate was something, but as you add the inhibitor, the reaction rate it decreases, okay, by adding the inhibitor. But if you add very much a large amount of the substrate, what will happen, the rate will be just sorry, the rate will be returned to the normal by adding the large quantity of the substrate. Okay. So, this is the this is called the competitive inhibition. So, as you can see from this flow chart also, and I think the flow chart it is not visible to you by much. So, I will just increase the size of the flow chart. Okay. So, now I think it will be clear to you. Okay, so as you can see, there is an enzyme molecule and this is the substrate molecule, okay, and there is an enzyme substrate, but when the inhibitor binds, so the substrate cannot bind and the product cannot be formed. but what will happen, like if you add large amount of the substrate, okay, so in presence of large amount of substrate, what will happen, the inhibitor molecules, they basically will be dissociated, and the substrate molecule, the rate of the substrate molecule binding to the enzyme, it will be increased, okay. And this is the graph, and you don't need to remember much about the graphs, okay. So you don't need to memorize the graph. So basically this is the Michaelis Menten graph of the compound, and this is the actually this is a what is said that in the example of the competitive inhibition. So there is a succinate molecule, and there is a enzyme called succinate dehydrogenase which catalyzes the succinate to the furanate, okay. But when there is a malonate, there is a presence, so in present of that the reaction cannot happen. So this is the example of a competitive inhibition, okay. So I will say you don't have to remember the graphs so much, just I mean remember what is the inhibition and the broad thing about the inhibition, and it will be enough, okay. So we will now move toward our next problem. Okay, I think somebody wants to join. Okay, so it was our problem number 4. Now we will move toward our problem number 5. So it says that the type of topoisomerase which generally relaxes DNA by removing negative supercoiling is type 1, type 2, type 3 and type 4. So you have to identify which is the correct type of topoisomerase which generally relaxes DNA by removing the negative supercoiling, okay. So the options are type 1, type 2, type 3 and type 4, and so anybody wants to answer this question in the chat box? Okay, we have answers like type 2 and for 5A, okay. So let us see. Okay, we have two options. I think there somebody is saying this is type 2, somebody is saying this is type 1. So let us see it. So the correct answer is type 1. So let us see. So the supercoiling of the DNA, okay. So the topology, so right handed supercoiling, it is the negative supercoiling, okay, and the left handed supercoiling, it is the positive supercoiling. So this is the topologies, and see, relux states is with no bends, and DNA must be constrained plasmid DNA or by proteins. So on revealing the DNA at on one position changes the superhelicity, and topology only defined for the continuous deformation, or that is no strand breakage, okay. So topoisomerase 1 and topoisomerase 2. So there are two kind of topoisomerase, they are main. So we will just have a brief looking about their comparison. So for the topoisomerase 1, so these enzymes which cut one of the two strands of double stranded DNA, relax the strand and reanneal the strand, okay. And the topoisomerase 2, these enzymes which cut the both strands of the DNA helix simultaneously in order to manage DNA tangles and the supercoils, okay. The first one, they generate single strand break, and for the second one they generate double strand breaks, and the first one they occurs in eukaryotes, and the second one this occurs in both eukaryotes and the prokaryotes. And the first one they does not require ATP hydrolysis, but the topoisomerase 2 they require ATP hydrolysis. And the three subclasses of the topoisomerase 1 are there: type 1A topoisomerase, type 1B topoisomerase and type 1C topoisomerase. And for the topoisomerase 2 there are two subclasses, type 2A and type 2B topoisomerase, okay. And so the topoisomerases which generally relaxes DNA by removing negative supercoiling, it will be your topoisomerase 1. Somebody wants to join. Okay, so now we will move toward our next problem. Okay, so number 6, it says that which of the following is not true for a suicide substrate. Okay, number A, they are activated by the enzyme catalyzed reaction mechanism. Number B, they react irreversibly with the enzyme. Number C, they form a covalent bond with the active site once activated. And number D, they self-destruct as a result of an enzyme catalyzed reaction. So, we are 4 statements about the suicide substrate, and you have to identify which is not true about this kind of substrates. Okay. So, they are activated by the enzymes catalyzed reaction mechanism, they react irreversibly with the enzyme, they form a covalent bond with the active site once activated, they distract as a result of enzyme catalyzed reaction. So, you have to identify which statement is not true about the suicide substrates. So, do we have any answer for this question? Okay, somebody is saying that it is C, somebody is saying it is DB. So, we have different answers for that. Okay. So, let us say so, the correct answer is number D, they self-destruct as a result of a enzyme catalyzed reaction. So, this statement is not true about the suicide substrates. Now, let us look what is a suicide inhibitor and about the suicide inhibition. So, inhibitor binds as a substrate and it initially sorry, is initially processed by normal catalytic mechanism. Okay. It then generates a chemically reactive intermediate which inactivates the enzyme through the covalent modification, and the suicide because the enzyme participates in its own irreversible inhibition. And the suicide inhibition, it is a special type of irreversible inhibition of the enzyme activity. It is also known as a mechanism based inactivation. So, this term is very important, like it is called the mechanism based inactivation. Now, you can be given a question like what is the mechanism based inactivation. So, you have to remember it is nothing but the suicide inhibition. Okay. So, the inhibitor makes the use of the enzyme's own reaction mechanism to inactivate it, the mechanism. So, that is why it is called the mechanism based inactivation. So, in suicide inhibition, the structural analog is converted to a more effective inhibitor with the help of the enzyme to be inhibited. The substrate like compound initially binds with the enzyme, and first few steps of the pathway are catalyzed, and the new product irreversibly binds to the enzyme and inhibits further reaction. Okay. So, what happens basically in the suicide inhibition? So, one reactive intermediate which will form, and this reactive intermediate it will actually bind to the enzyme, and it will go for the covalent modification, and that is why the it is the suicide because it is called suicide because the enzyme participates in its own irreversible inhibition. Okay. So, I think it is clear what is the suicide substrate and what is suicide inhibition. Suicide inhibitor binds on which kind of enzyme? So, suicide inhibitors actually these are a class of the inhibitor. So, there are no particular class of the enzymes where the inhibitor can bind. Okay. Now, you can find out there are many examples of suicide inhibition, but there is nothing called a class of enzyme, specific class of enzyme where only it will bind and not it will not bind in other. If an enzyme have a I think it has a tendency, it will also participate in the suicide inhibition. So, there is no specific class of the enzymes which will be inhibited by this kind of inhibitor. Okay. Now, we will move toward our next problem. Okay, so, problem number 7, it says that which of the following statements is not true about Km and Vmax. So, Vmax is the maximum rate at which particular enzyme catalyzed reaction can proceed. A small value of Km tells us that the enzyme binds strongly to the substrate. Km is the concentration of the substrate at which the rate of the reaction reaches Vmax, and the large value of the Km tells us that the enzyme shows little specificity over the given substrate. So, you have to identify the statement which is not true for the Km and Vmax. So, do you have any answers for this question? Okay, somebody has says C. So, C is the most common answer, I think. So, let us check the correct answer. Okay, so number C is not true, that Km is the concentration of the substrate at which the reaction reaches the Vmax. So this is the equation which is called the Michaelis-Menten equation, okay. And this is the curve which is called the Michaelis-Menten curve. So as you can see, so in this it is a very important reaction, and you all of you must remember this reaction, this formula, okay. So V0 is the initial velocity, and which is in the terms of moles per times, okay. So the like mole per second, like this, and the S is the substance concentration, which is the molar concentration. Vmax, it is the maximum velocity of the enzyme catalyzed reaction, and Km is the substrate concentration at the half Vmax, okay. So when there is a Km is the substrate concentration at the half Vmax. So when the Vmax is half, we have to just plot these two lines on the graph, and we will have the substrate concentration, which is the called the Km or Michaelis-Menten constant, okay. Somebody wants to join, okay. So this is called the Michaelis-Menten constant, and as you can see from the graph, like this blue line, it's indicate when the V0 equal to Vmax S by Km, means when the substrate concentration is very less than the Km, the substrate concentration very less than the Km. So this is the representation of that. But when the substrate concentration is very greater than Km, then this is the representation of this kind of reaction. So V0 will be this. So this is actually basically, so what will happen? So from this equation, as you can see, if your Km is very less than very less than at substrate concentration, and which occurs at the higher substrate concentration, like this kind of place, okay. Now, at the higher substrate concentration, the Km is less greater than this concentration of S. So we can neglect this term for the equation, and this del S del it can be cancelled out, and V0 will be equal to Vmax, and we get this value, okay. Now what will happen when, okay, I will just erase this part, and what will happen when the Km is very large greater than the when Km it is large than very large greater than delta S, means at the low substrate concentration, what will happen, like if the substrate concentration is low, we can neglect this term for the denominator, and we get this kind of equation, okay. So and the unit of the V0 is molar per minute or per second, as we can say, and I think it is clear what is Km, what is Vmax, and what is about the equation. So if there is any query, I will check, okay. So if you have any query, again I am saying, if you have any query, any doubt regarding any point of the session, please do write in the chat box, okay. At the end of the session, if not possible in the middle, at the end of the session, definitely I will solve your queries. So I think this is clear. The problem number 7, it is clear to you. Now we will move toward our problem number 8, okay. So problem number 8, it says that fetal hemoglobin has a higher binding activity for oxygen than it does for adult hemoglobin. In comparison to the adult oxyhemoglobin dissociation curve, the fetal oxyhemoglobin dissociation curve will be shifted to the left and display a lower Km value, shifted to the right and display a lower Km value, shifted to the right and display higher Km value, and shifted to the left display higher Km value. So you have to identify the correct options for this phenomena, where the fetal hemoglobin has a higher binding affinity with oxygen than the adult hemoglobin, and in comparison to adult oxyhemoglobin dissociation curve, the curve of the oxyhemoglobin for the fetal oxyhemoglobin dissociation, how it will change if we compare two different curves, okay. So anybody wants to answer this question? Okay, we have answers like A, and we have answers like C. Lower, somebody says lower Km means stronger binding, okay. So let's check the answer. So yeah, number A is correct. It will shift it to the left and display lower Km. So this is the hemoglobin, and if you can see, this is the adult hemoglobin and this is the fetal hemoglobin. So this is for the adult hemoglobin. What happens? As we know, there are two alpha subunits and there are two beta subunits. Okay, so the two beta chain and two alpha chain, it comprises of a adult hemoglobin, hemoglobin A. And for the fetal hemoglobin, which is called HbF, and it has two gamma chains and two alpha chains. And the polypeptide gamma chains enable to fetus hemoglobin to have greater affinity to the oxygen, and that can ensure enough oxygen is being delivered to the organs of the developing fetus. And it is the dissociation curve. Okay, the fetal hemoglobin has a higher affinity for the oxygen at all partial pressures. So this ensures that the oxygen transferred to the fetus from the mammalian placental bloods across the placenta. Okay, somebody wants to join. Okay, so yes, wait a minute. So fetal hemoglobin has a higher affinity for the oxygen at all partial pressures, and this ensures that oxygen is transferred to the fetus from the maternal blood across the placenta. The partial pressure of oxygen, which is denoted by this PO2, in the fetal tissues is very low due to the high metabolic rate associated with the fetal growth rates. And although the fetal hemoglobin has a higher affinity for the oxygen, in such a low partial pressure of environment of the fetal tissue, it unload oxygen readily, and at a birth the fetal hemoglobin is replaced by the with the adult type of hemoglobin. Okay, so as you can see from this curve, like there is a, this is the curve for your adult hemoglobin and this is the curve of the fetal hemoglobin. So this fetal hemoglobin curve is shifted toward the left, and because due to that it will show a lower Km value, because we all know what is the Km. So this is the substrate concentration at the Vmax. So if you can say it is the 50%, and it is the Km value is here. So and for the adult the Km value will be here. Okay, so which is definitely higher. So it will show the lower Km value and the curve is shifted toward the left. Okay, so this is the percentage of the saturation of the oxygen with the hemoglobin, and this is the partial pressure of the oxygen. Okay, so at the same partial pressure for the low partial pressure, it is more saturated. So I think it is clear. If you have any doubt, please let me know. Okay, so we will move toward our next problem then. Sorry. Okay, so problem number 9, we will just do it. So it says that which of the following amino acids will be most prone to the reaction with an irreversible inhibitor, and the options are as follow: number A tyrosine, number B threonine, number C histidine, and number D lysine. So you have to find out which of the following amino acids will be most prone to the reaction with an irreversible inhibitor. You can write the answer in the chat box. I will check it, then I will go on solving this problem. So do we have any answers for this question? Okay, somebody is saying A. For the 9, the most answers are like A. What is okay, let's check it. Number A, it says tyrosine. Okay, let's see which of the following amino acid will be most prone to the reaction with an irreversible inhibitor. Okay, so your correct answer is number D, which is lysine. So before solving the question, we will just see all the structures of the following amino acids. Okay, So, what is a irreversible inhibitor? So, the irreversible inhibitor is the inhibitor which permanently blocks the action of the enzyme. Okay. So, this is the structure of the lysine, this is the structure of the tyrosine, this is the structure of the threonine, and this is the structure of the histidine. Okay, somebody wants to join. Okay, there is which is the functional group is responsible for this. It is the side chain of the amino group. Yeah, it is correct. Okay, the number D is correct. So, let's see. We will learn in detail. So, this is the structure of lysine. This is the tyrosine. This is threonine, and this is the histidine. So, as we all know, like this is the your alpha for alpha amino acids, this amine and this OH groups, this both two groups will be used for the formation of your peptide bonds, right. So, what will happen, since there is another functional group which is present in the molecule, like for the lysine, tyrosine, threonine and histidine, the side chain of the amino acids are like this. It has a free NH2 group. Okay. It has a phenolic OH kind of group for the tyrosine. The threonine, it has this OH kind of group only, and for this we have this imidazole kind of ring. Okay. So, if you see the functionalities, this only this free NH2 group, it has a lone pair, and this lone pair is more readily available to attack a substrate by this lone pair. So, okay. So, you can say that OH also have a lone pair, but since the OH oxygen has a higher electronegativity, so this donation of this lone pair and by reaction with this lone pair is not that much possible, and for the imidazole ring, this lone pair is involved in aromaticity of this imidazole ring. So, this lone pair will not also be taking part in any kind of reaction. Similarly, for tyrosine, this lone pair is more involved in the resonance like this. So, it will not be available for reacting with the substrate. Okay. Now, what is we will just take a more highlight into the irreversible inhibition. So, in irreversible inhibition, the inhibitor binds to the enzyme irreversibly through the formation of a covalent bond with an enzyme permanently. Thus, they inactivates the enzyme. So, we will also learn something about reversible inhibition and versus irreversible inhibition. So, the first one, the reversible inhibition, the process of binding inhibitors to the enzyme through the monovalent interaction, so that once removed they allow to restoring the enzyme function. But for irreversible inhibition, the process of binding inhibitors to an enzyme through the covalent interaction. So, their dissociation takes a long time, permanently removing the covalent action. Okay. The enzyme action, reversible inhibitors bind to the enzyme through non-covalent interactions such as hydrogen bonds, hydrophobic interaction, ionic bonds, and in the reversible enzyme inhibition. But for the irreversible inhibitors, they bind to the enzymes through the covalent interaction, which modify the amino acid residues by reactive functional group in an inhibition mechanism. The first one, the enzyme inhibitor complex dissociates very quickly, but for the irreversible case, the dissociation happens very slowly. Okay. The enzymatic action can be restored in the reversible inhibition, but in case of irreversible inhibition, it takes a long time to restore the enzymatic action. And there are various type of this reversible inhibition like competitive, uncompetitive, non-competitive or mixed inhibition, but for the irreversible occurs through the covalent inactivation of the active site. So, the covalent inhibition is also called the irreversible inhibition. Okay. So, now I think there were some queries about the why the which functional groups will be acting as a irreversible. I think it is the answer. Okay, so if the NH2 responsible, then why threonine is not the correct answer? Yeah, so threonine will not be the correct answer because as I said that the oxygen, this alcoholic oxygen, this is not so much prone to form a covalent interaction. Okay, see this oxygen, it is more electronegative than this nitrogen, and if it forms the covalent bonding, what will happen, this hydrogen has to, there is one more thing, the hydrogen will have to be released. So, if the NH2 forms the covalent bond, so it will be like say it is the enzyme. Okay, is the enzyme, and if this forms, so it will be NH and then it will be lysine molecule. So, there is one hydrogen molecule present which will capable of doing the hydrogen bonding, which will stabilize the whole thing. But in case of this threonine, if it forms a bond, so it will be enzyme oxygen and then it will be rest of the threonine molecule. So, there won't be any hydrogen molecule present. So, there won't be any hydrogen bonding which will not actually stabilize this enzyme inhibitor complex. Okay. So, in case of the lysine, it is only possible to donate by donation of this lone pair, and by for its acting as a nucleophile is more, as you all know that NH2 nitrogen lone pair, it is more nucleophilic than the oxygen one. Okay. So, that is the reason, like this lysine will act as the irreversible intake part will most prone, and it says that it is most prone. Okay. I have not said that threonine will not take part, but lysine more readily will take part in the irreversible inhibition. Okay. So, when you read this question, you have to read the question also carefully. Like, it is not said that which amino acid will only be the acting as a irreversible inhibitor. It says that which is most prone, and I have not said that threonine will not act as all. It may act as an irreversible inhibitor, but the probability is much less than the lysine. Sorry. So, now I think it is clear. If it is, then we will move toward our next problem. So, problem number 10, it says that what is the ratio of V0 by V max when the substrate concentration equal to 7 km, and the options are number A 7 by 8, number B 1 by 7, number C 5 by 7, and number D 8 by 7. So, this is a quick math, and I want all of you to try to solve this. So, what is the ratio of V0 by V max when delta S equal to 7 km? So, I want all of you to answer this question, the mathematics part. Okay. What is the ratio of V0 by V max when delta is equal to 7 km? Just take 2 minutes, and it is a very easy question, easy math, and try to solve this. What is the ratio of V0 by V max when delta S equal to 7 km? All you have to just put this value of delta S in the Michaelis-Menten equation, and if there is any answers. Okay, somebody is saying A, somebody is saying B, somebody is okay. 8 by 7 we have answer like B, A. Okay, let's check it. What is the correct answer? So, the correct answer will be A. So, whoever have answered A, you are correct. So, this is the math. Okay. This is the Michaelis-Menten equation, and this is the math. So, what is the ratio of V0 by Vmax? So, as you can see, V0 equal to Vmax by S by Km plus S. Okay. Now, if you just take this Vmax at this side, at your left hand side, what will we have? We will have V0 by Vmax, and we have delta S divided by Km plus S. So, in the equation it says that S equal to 7 Km. So, we have this 7 Km divided by Km plus 7 Km. When Km cancel out, and the answer is 7 by 8. So, did you understand how the math is solved? Because we have few doubts about the question, there were few queries. Yeah, 7 by 8 is the correct answer. So, I think it is clear how the maths is solved. So, till now if you have any doubts, please write in the chat box, and we will take so there are 10 questions, so total we will solve today 20 questions, and since it is halfway, so we are going to take a 5-minute short break. Okay, and we will join after just 5 minutes. You can recapitulate what we learned today till now, and if you have any doubt regarding any point, any question, so you can write in the chat box. So, I am taking I am giving all of you and for 5 minutes of a break, So you can if you have any doubt, anything, you can write in the meanwhile in the chat box, and after 5 minutes, and we will just join. Yeah, so we will join at sharp 6:55. Okay, so it is 6:49 right now, so we will join at 6:55. Okay, and if you have any doubt, anything, write in the chat box. Okay, yeah. Okay, hello. So, is my voice is audible? Yes. Okay. So, I think all of you have got a good break of 5 minutes. So, we will resume our class. Okay, we have 10 more questions to solve, and till now I assume you have understood the things about the how the questions have been solved, and you guys are also answering it very well. So, let us move forward. So, today we will solve a couple of maths also in the later in the class. So, okay, now problem number 11. So, it says that which inhibition study deals with the decrease of the value of both Vmax and Km with the increase of the inhibitor concentration. So, as you increase the inhibitor concentration, both the values of Vmax and Km will increase. Okay. Okay, sorry, I was incorrect. So, with the increase of the inhibitor concentration, both the values of the Vmax and Km will decrease, and you have to find out which kind of inhibition is this. So, the options are A competitive, B non-competitive, C uncompetitive, and D suicide inhibition. Okay. Which inhibition study deals with the decrease in the value of both Vmax and Km with the increase of the inhibitor concentration? So, do we have any answers? Okay, somebody have says uncompetitive. B, somebody has also 2 to 3 people have answered this. Okay, so let's check out the correct answer. So yeah, it is the correct answer is the uncompetitive inhibition. So these are the graphs actually are called Lineweaver-Burke plot for the inhibition. So basically in the Michaelis-Menten equation and the curve you have said that we plot Vmax by the substrate concentration, and in this case we plot 1 by V in the y axis and 1 by S in the x axis. Okay. Now this is for the red lines are always when there is the inhibitor present, and the blue line is when there is no inhibitor. Now first let us check out the competitive inhibition. So for the competitive inhibition, what will happen as the inhibitor concentration is increased. Okay, when the inhibitor concentration is increased, the Km will be increased and the Vmax will be unaffected. Okay, so if the Km will increase and Vmax will be unaffected, and the Km by Vmax is the slope of this curves. Okay, so for the Lineweaver-Burke plot, the slope of the curve, the slope is denoted by the Km. Okay, sorry. So somebody wants to join, I think. Yeah, okay, yeah, it's C. Okay, so for the this is okay. So as is I said, the this lines for this particular plot of the Lineweaver-Burke plot, this straight line, it has a slope of this Km by Vmax. So this is the slope. So as you can see for the competitive inhibition, so this is how the plots look like for the presence of inhibitor and presence of no inhibitor. Okay. Now what happens, like the value of Km it increased and Vmax it remains unaffected. So what will happen to the slope? See, if the Km is in the numerator, so if the value increases, the slope will also increase. So you can see this line is much steeper than this blue one. Okay. And so this is the your case of the competitive inhibition. So always remember, for in case of competitive inhibition, the Km value will increase, but the Vmax value is unaffected. And now let us come to the uncompetitive inhibition. Now the uncompetitive inhibition, both the value of the Km and Vmax will be reduced. Yeah, so in case of uncompetitive inhibition, both the values of Km and Vmax is reduced. Okay, so what will happen if the both values are reduced? So in case of that, so the numerator and denominator both will be reduced and the slope will be same. So as you can see, the slopes of these two lines are same. But what happens, like see, in case of this actually when the extrapolation of this line cuts at this position which is given by 1 by V max, okay, which is the intercept. So, the intercept of these lines which are given by 1 by V max. So, for in the first case the V max one unaffected. So, 1 by V max will also be unaffected. So, whether you add an inhibitor or not, both line will have the same intercept. In presence of inhibition, in presence of inhibitor or no inhibitor, the lines will have the same intercept since the V max is unaffected. But in case of uncompetitive inhibition, what will happen, since the both Km and V max is reduced. So, if V max is reduced, then what will happen with 1 by V max? So, 1 by V max it will be increased, okay, in presence of inhibitor. So, since the intercept will also be increased. So, if it is the 1 by V max for the without any inhibitor, with presence of inhibitor, this is the intercept and the value is increased. Since the Km value is decreased, 1 by Vm value, the value of the intercept is increased, okay. And for the non-competitive inhibition, the Km remains unaffected. Okay, since the Km remains unaffected, so as you can see, this both lines, if you extrapolate in the negative side, so it will have your 1 by minus 1 by Km, so it will be in it will come at the same position, okay. But the V max is reduced. So, since the V max is reduced, so what will happen? The V max is reduced, so the similarly we will see that the value of the intercept will increase. Now, I want to ask, like, if you understood these three curves, okay. So, sometimes this kind of curves and presentation, so I can have to solve the problem and the assignment. Okay, so actually for the this kind of this slides, okay, I always share the slides, okay. So, for the NPTEL side, as you know that actually I am a PMRF fellow from the IITISM Dhanbad. So, what will happen, like every week we take the class and we upload the slides and the video of today's lecture. If you in case if you actually missed anything at any point due to the poor internet connection. So, both the things I upload in a sheet and that sheet has to be provided to you by the NPTEL website, okay. So, I myself cannot share it with you from my side. So, it will be uploaded to the SWAYAM website soon, I think, if it is not uploaded till now. So, soon it will be uploaded in the SWAYAM website. So, you can check it from the slide, you can check the slide from there, okay. So, I want to know if you understood these three graphs, okay. So, these three graphs are actually very easy, but just you need to just look at the things carefully, like which value is increasing, which value is decreasing, and you have to just check out this thing very carefully. And if you see the things, then you will understood it better, okay. So, did you guys understood? Because we cannot find it properly. Yeah, obviously I will definitely show the recorded. So, this whole meeting is being recorded, okay. So, I will share the recording also with you, so that you can check it out later, okay. And it will be also uploaded in the YouTube, and the YouTube link will be provided to you. So, if you have any doubt, if you miss anything during the lecture due to poor internet connection, you can definitely check it out later, okay. And for the negative sign, as you can know, like this is 1 by S, okay. So, what is Km? As we said, Km is the substrate concentration at Vmax by 2, okay. So, let me check the pen. So, so Km is something equivalent to your substrate concentration, okay. So, if it is the positive x axis, so it has the unit of 1 by S. So, this negative x axis, it will be have unit of 1 by S, which has a negative sign. So, minus 1 by S, okay. And where it extrapolates this two line, it will be have the value of 1 by Km. So, the negative signs basically be due to, since it is the at the negative x axis, okay. So, now I think it is more or less clear this problem. So, it is very easy. If you check it out later and you read it carefully, you will understand it like how the plot, how the things are going on here. So, this was your problem number 11. So, look at it carefully. If you have any doubt, any more doubt regarding this plot, tell me later or tell me right now. Okay, so I assume the question is clear to everyone. Okay, so now quickly I will move toward the next problem. So, problem number 12, it says that So this is a mathematics, okay. So I want all of you to solve this by yourself, and I will gradually tell you the answer and show you how it is being solved. So actually this kind of Michaelis-Menten constant kinetics, so it will be better if you solve few mathematics for this, okay, because maths can come, very simple maths can come, and we solved one in the previous slide. So this is another math. So it says that consider the following plot of the velocity versus substrate concentration of the enzyme catalyzed reaction obeying Michaelis-Menten kinetics. Okay. So with an initial enzyme concentration of 10 to the power minus 5 micromolar. So the turnover number for the reaction is number A 8000, then we have 8 lakh, and then we have 40,000 and 4 lakh. Okay. So this is the graph. As you can see, this is the graph, and for it says that with the initial enzyme concentration at 10 to the power minus 5 micromolar. So you have to find out the turnover number of the reaction. So please try to solve the problem. I will gradually show you the answer and how it is solved. So do you have any answers? Okay, I will give you some more time to solve this since it is a mathematics. Try to solve it. So has anybody answered it? If you cannot answer it, it is fine, because I will let you know. Okay, we have one answer like B. So let's check out the answer. Okay, so yeah, B is the correct answer. So whoever have answered B, it is correct. Okay, now let's see how it is solved. Okay. Okay, so the Michaelis-Menten equation, as we all know, okay, sorry, Michaelis-Menten equation, as we all know, what is the equation? Like it is, this is the broader form of the Michaelis-Menten equation. Okay, so like we all know that the very famous short form, like it is V0, V0 equal to your V max. Okay, somebody wants to join. So we all know the traditional very short form of the Michaelis-Menten equation, which is your V0 equal to V max, and then there is a S, which is a substrate concentration, and there is divided by Km plus S. And please pardon my bad handwriting, I am not used to writing it in the PPT like this. So I think you know all the, and it is also written here. Okay, and so the equation is also written here. Okay, so what happens, like now the what is the, it says, like it says that at a very high concentration, the delta, when there is very high substrate concentration, what happens, like this delta is 0 is much greater than Km, which I have said you like before. Okay, so if what happens, like in the previous one question I tell you this thing. Okay, if the delta is 0 or the initial substrate concentration is very high, so we can neglect this Km in the denominator. Okay, and if we neglect this Km in the denominator, so what will the equation look like? So if the Km is negligible, okay, so we will have like a V0 equal to your V max, or your K2 is K2S0, it is also, sorry, K2E0, it is called also V max. Okay, so V max into, there is S, and we have S in the denominator only if we neglect the Km. Okay, so what will happen, this S and S cancel out, and we get this equation, like the rate equal to K2E0 equal to V max. Now, that is the rate attains the maximum value, and the reaction is 0 ordered with respect to the substrate concentration. So now when the rate it is 0 order reaction, means there is no substrate concentration dependence. Now this value K2, which is called the turnover number of the enzyme, and for the any enzyme, any catalyst, the turnover number, this is very important term. Okay, so as you know, turnover number, it is a very important term. For the catalyst also we use this term, or turnover number. So higher the turnover number of a catalyst or enzyme, the more active it is. Okay, so turnover number of an enzyme. So this K2 is called the turnover number of the enzyme. Okay, this K2. Yeah. So this K2 is called the turnover number of the enzyme. So it represents the number of molecule converted to product in unit time by one molecule of enzyme. So what is the turnover number? One molecule of enzyme per unit time, it converts a certain number of the molecules, and that number of molecules is called the turnover number for a particular enzyme. So higher the turnover number means per unit time one molecule of enzyme converts higher number of the molecule to the product, means it is more efficient. So higher turnover number of enzyme and catalyst means it is a more efficient enzyme or a more efficient catalyst. Okay. So according to the equation, E0 equal to 10 to the power minus 5 micrometer. So it is said that the initial enzyme concentration is given to you, which is 10 to the power minus 5 micromolar. Okay. And Vmax equal to 8 micromolar per minute, and this Vmax value is can be taken from this graph. So as you can say, this is Vmax, your the highest your velocity, which is Vmax, it is coming of 8, and the unit is micromole per minute. Okay. So Vmax is 8 micromole per minute from the graph, and E0 is provided to you from this question, that the initial enzyme concentration 10 to the power minus 5 micromolar. Now K2, what will be the K2? K2 value will be Vmax by E0, which is 8 micromolar by 10 to the power minus 5 micromolar per minute, which is 80 which is 8 lakhs. Okay. So this is the final answer. Now I want all you to respond if you understood this problem or not. Okay. If you don't understand this problem, tell me right now. Okay, because this is a very easy or but very important question. Yeah. Turnover number defines the efficiency of an enzyme. So not only enzyme, the catalyst also have a turnover number. So this is a very important criteria. So when you are working with an enzyme, you are working with a catalyst, this turnover number or this term is very important, because it actually gives you the efficiency. Higher the turnover number, higher is the efficiency of that enzyme or the catalyst. Okay. So I think did you guys understood this problem or not? So please respond in the chat box if you have any problem understanding this math. Okay, because it's very important point, important topic. Okay, so how to calculate Vmax from E0? Okay. Okay, so Vmax from E0, calculation of Vmax from E0 is not cannot be done without any knowledge to the K2. Okay, you have to either provided any value. So in this equation we have three point terms, right? Like one is Vmax, one is E0, and one is K2. So if you are not provided with two values, we cannot calculate it. So from to calculate Vmax from E0, you should have known the prior information. You have to have some prior information about the turnover number of the enzyme. So alone from the E0 value, you cannot determine the Vmax value. Okay, and if you determine the value, it will be in terms of the K2. Okay, so this is the point. You cannot calculate the Vmax from the E0 itself. Okay. So anyway, I will share the PPTs to you later also. You can check this math also by yourself, and I think this is clear to more or less to all of you, and I will then move toward our next problem. Okay, so next problem, it says that it is also a mathematics. So I also want you also all to try this by yourself. So it says that consider the following plot of 1 by V0 versus 1 by S in the Lindweber-Burke plot. Okay, and the results obtained of the graph is the intercept value is 0.1 micromolar minute inverse, and the slope is 5 into 10 to the power 3 minute. And what is the Km value of the reaction? Now if carefully, if you remember, just before back 1 or 2 question back, I discussed this Lindweber-Burke plot, and what is the slope, what was the intercept, all I discussed in the previous slide. Okay, so if you just remember what is the slope of the that line, what was the intercept of the line, and you just add the values there, and we will easily find out what is the value of the Km. Just try to answer this question, try to solve it, take few 2 to 3 minutes, and try to solve this, and I will discuss also with you the solution. Sorry. Okay, join. Okay, so you need to see the graph. I will not show you the graph because I think I have told you, like you have to remember, right, how the graph is looked, because all the time when this kind of maths will be provided to you, you will not be given the graphs. Okay, so you have to have know how to plot the graph. And anyways, one more thing, if you don't remember this kind of plot, okay, so there is a basic equation. You all know the Michaelis-Menten equation, right, which is a very basic equation. What was the equation? Well, it was V max equal to okay, somebody wants to join again. So you if you don't remember, like say you don't remember right now what is the Lineweaver-Burke plot, okay, so you remember what is the Michaelis-Menten equation, right? It is V0 equal to V max into S divided by Km plus S. So it is the Michaelis-Menten equation. Now from this equation itself you can derive the equation for this Lineweaver-Burke plot, okay. So just to know how what is so you know all the straight line equation, like y equal to your mx plus c, right? You know this equation of the straight line, like m is the slope of the line, c is the intercept of the line, and this y equal to, now you have been said that to consider the plot of 1 by v0 divided by 1 by s. So your y equal to 1 by v0, it is equal to y, and 1 by s, it is your x. Now try to rearrange this equation into this manner, like 1 by v0 equal to slope means m into 1 by s plus your intercept c. So try to rearrange this equation in this manner, okay. Since the y is given you, the x is given to you, you just have to rearrange this parent equation in this manner. So from that you will get the term for the slope and the intercept. So if you don't remember the graph at the point of your examination or at any point, you know the basic equation, remember the basic equation and derive the graph, derive the equation for the Lineweaver-Burke plot, okay. So anybody who have derived this and or you have answered this question? Okay, so we have an answer. Km is 5 into 10 to the power 4. Okay, we have the answer C. Let's check out. 5 into 10 to the power 4. The answer is C. So correct. The answer is 5 into 10 to the power 4 or C. So now I will show you. So I think you understood how I told you, like you know how to do it, okay. Okay, this cannot be erased, I don't know why. One second, I'll just delete it. Okay, so this is your whole mathematics. So this is your Lineweaver-Burke plot, okay. So the slope is Km by V max and the intercept is 1 by V max. Now the Lineweaver-Burke plot is associated with the equation 1 by V0 equal to 1 by V max, which is your C, plus Km by V max, which is your M, and 1 by S, which is your X, okay. So it is y equal to C plus mx, kind of it is written here like this. Now plotting, we get the similar information, like the intercept is 1 by V max and the slope is Km by V max. Now from the question we have the value of the intercept, which is 0.1 micromolar per minute inverse, okay, and the V max is 10 micromolar per minute. So the slope, which is have the equation Km by V max, so Km equal to slope into the V max. So this is the slope and the V max we have, and this is your final answer. So take 2 to 3 minute time and look at the equation carefully, look at the solve carefully, and let me know if you don't understand anything about this problem or about this solution and anything. So as I said, it is not always possible to remember each and everything of equations, okay. So yeah, your answer is correct, and also somebody also have answered this. So the answers are correct, and how it is being plot. And as I said, if you don't remember this Lineweaver-Burke plot or any plot at your Isha, it is not possible to memorize everything, but you all memorize the Michaelis-Menten equation, right? So, it is very easy to derive this kind of equation from that. Like during my master's day or time, I also didn't memorize all this thing. When there was a need, I just derived the equations from the main Michaelis-Menten equation. It is more handy at the point of the examination before, because if you memorize, you can easily actually forget anything, but if you derive it, it will never go wrong. Okay. So, look at the answer carefully, look at the solve carefully, and let me know if you do not understand anything. Okay, so I assume you understood this problem. So, I will move forward to our next problem. Okay, so this problem number 14, it says that in a particular human DNA, it has been observed that adenine is present in 30%. So, what will be the percentage of cytosine in the DNA sample? Options are like number A 30%, number B 25%, number C 70%, and number D 20%. So, this is, I presume, easier question, quite easier, and just try to solve it. So, in a particular human DNA, it has been observed that adenine is present in 30%. So, what will be the percentage of cytosine in that DNA sample? So, do we have any answers for it till now? Okay. Yeah. Okay, so sorry, I think my connection, I just lost my connection. Okay, I will share it again. Okay, the screen is visible, right? I lost my internet connection in between. Okay, okay, sorry, the question is not displayed. Okay, okay, sorry. So, there was a internet issue here. Okay, so I will just show you the question again. So, this was the question. So, in a particular human DNA, it has been observed that adenine is present in 30%. So, what will be the percentage of cytosine in the DNA sample? The options are number A 30%, option B 25%, option C 70%, and option D 20%. You have to find out the percentage of the cytosine in the DNA sample. So, let us check out if anybody has answered it. Okay, D and 20%. We have some answers like D, some answers as 20%. So, let us check out. Okay, so correct answer is number D 20%. So, this is the rule of the base pairing for the DNA and RNA. So, cytosine is paired with guanine, adenine is paired with thymine in case of DNA. In case of RNA, the cytosine is paired with guanine and the adenine is paired with uracil. Okay. So, what happens? Like this is the Hello. Okay, so sorry, it was a internet issue here. Okay. Mm, so sorry for the disturbance. I will just share it again. Okay, can you please tell me if you can see the slides? Okay, due to some internet issue, I just lost the connection. So do you see the slide? Is it visible to you? Anybody please, if my voice is audible? Yeah. Okay, okay. Thank you so much. So sorry for the disturbance. So okay. So this is the number your problem. Okay. So yeah, somebody. Okay. So as I said that adenine makes the hydrogen bond with the thymine. Okay. So since there is 30% of adenine is present, the percentage of thymine will also be 30%. So thus the two remaining bases, the cytosine and guanine, they consist total of 100 minus 30 plus 30 means 40%. Now cytosine and guanine, they make hydrogen bonding to each other. Hence they will be present in the same amount. Hence the percentage of the cytosine, it will be 40 divided by 2, which is 20%. Okay. So this was a relatively easy question. So I think do you guys understood? Okay. So I explained how it is 20%. So now did you understood that how it is 20%, since 30% adenine is pairing with your thymine. So if 30% of adenine is present, the thymine percentage will also be 30%, means adenine and thymine altogether will make a 60%. Now what is the remaining percentage? It will be 40%, which will be equally divided to the cytosine and the guanine. Okay. So the question, it is asked that what is the percentage of the cytosine in the DNA sample? So it will be 20%. Clear. Okay, good. So now I will move toward my next problem, and there might be some internet disturbance, so pardon me. Just you remain in the call. Okay, so it will be resolved soon. Okay, so we will move toward the next problem. So the problem number 15, it says that the sister strands of the DNA molecule are number A, parallel and complementary, number B, antiparallel and complementary, number C, parallel and identical, and number D, none of the above. So you have to identify like the sister strands of the DNA molecule are of which type. Are they parallel and complementary, or they are antiparallel and complementary, or they are parallel and identical, and none of this. Okay. So do we have any answer for it? Okay, we have answers like B and A. So we have two options like B and A. So let's check out the correct answer. Okay, so the correct answer, it will be number B, antiparallel and complementary. So this is the antiparallel DNA strands, as you can see. So what is antiparallel means? Like we all know that there is a 3' to 5' thing happens in the DNA and RNA molecule. So if it is a so this 3 and 5, it comes from this number or numerology of this sugar moiety. Okay, so if there is a 1, 2 and 3, so there is a 3 to 5 linkage or phosphate linkage from the two different nucleotides. Okay. So what happens, like if from one chain goes from the 5' to 3', other chain it will go from the 3' to 5'. So it is the antiparallel. And complementary means if one strand it has a thymine, the another strand will have the complementary base, which means it will be have adenine. It will have adenine, okay, or it have, if it is having guanine, it will be having cytosine. So it means complementary. Complementary in that in sense, like if adenine is present, the other chain will not also have the adenine here. It will be at the complementary base, means it will be have the base with which it will have, form the hydrogen bonding. Like adenine forms hydrogen bond with thymine and guanine forms cytosine. So if one chain it has the thymine, other chain will be have the complementary DNA base, means the adenine. Okay. So I think it is clear. Okay. So it was rather normal question. So that's how it is the antiparallel and complementary DNA strands, sister strands of the DNA molecule. Now we will move toward our next problem, problem number 16. So, it says that how many nonsense codons are present in the amino acid coding system. Your options are as follow, number 2, 3, 1 and 4. So, you have to identify how many nonsense codons are present in the amino acid coding system. Try to answer it. I will just after showing you the answer, I will let you know what is the codon, which is the nonsense codon and what is all about. But first try to answer it by yourself. Do you have any answers for that? Okay, B and 3. Okay. So it is correct. The correct answer is 3. So 3 nonsense codons are present in the amino acid coding system. So these 3 codons, which are called the nonsense codon, also are called the termination codons. Now codons, what is codons? Codons actually are this 3 nucleobase code, okay, and a particular codon which is 3 nucleobase code, like UUU means 3 uracil and UUC means 2 uracil and 1 cytosine. So these particular 3 nucleobase codes, every code is gives us one particular amino acid, okay. So when there is a translation happens, mean there is a peptide chain formation is happened by the RNA molecule. So this codons help to join one amino acid. So if there is a codon, so this is the AUG is called the start codon, and it is the it start by the translation by adding the methionine amino acid, okay. So AUG, it stands for the methionine. So there are 3 codons which are called the nonsense or termination codon, which don't actually incorporate any kind of amino acid. They are also called the stop codons. So these codons which provide the signal for the termination of the polypeptide chain are known as the stop codon or termination codons. So there are 3 termination codons. They are UAA, UAG and UGA, and these are called the ochre, amber and opal. And since stop codons do not code for any amino acid, they were earlier called as nonsense codons, okay. So you just remember, like there are 3 nonsense or stop codons which are UAA, UAG and UGA. We do not incorporate any amino acid, and they signals actually to stop the polypeptide chain formation, okay. And also remember this AUG, and you don't need to remember every for which codon incorporates which amino acid. You don't need to remember everything. Just remember AUG, it codes for the methionine, and it is the start codon which actually starts the polypeptide synthesis, okay. Okay, so I will now move toward the next problem. So problem number 17, it says that which of the following statements regarding ribosome is false. Number A, ribosome of prokaryotes is smaller than eukaryotes. Number B, ribosome is made up of ribosomal RNAs and protein. Number C, the S subunit of the ribosome stands for the Sedgwick unit. And number D, eukaryotic ribosome, it contains 50S and 30S subunit. So about ribosome, you have to find out which one is the false statement. Just read every statement carefully and just tell me in the chat box which is the false statement regarding the ribosome. Okay, so we have answers like C, B and D. Okay, yeah, I will show the question of the 14th slide at the end, okay. I will repeat that question at the end, because that at that time there was an internet disruption. So I will just show you the question number 14 at the end of the every question, okay. Okay, so correct answer, I mean the false statement regarding the ribosome is number D. The eukaryotic ribosome contains 50S and 30S subunits. So this is the false statement regarding the ribosome. So this is the prokaryotic ribosome, and it is the eukaryotic ribosome. So, the prokaryotic ribosome, it is called the 70S, and the eukaryotic one, it is called the 80S. So, for the prokaryotic, it have two subunits like 50S subunit and 30S subunit, and for the eukaryotic, it has two subunits, one is 60S and one is 40S. Okay. So, this this is the basic difference between the this is the basic difference between the two RNAs, and the ribosome of the prokaryotics are smaller than the eukaryotics. It is correct statement, and the ribosome are made up of ribosomal RNAs and proteins. Okay. So, this RNA is here which is mentioned, it is the ribosomal RNA. Okay. And the S subunit of the ribosome, it stand for the Sedberg unit, and for the last point it was false, because for the prokaryotic ribosome it has 50S 30S subunit, but for the eukaryote it has the 60S 40S subunit. Okay. I will show the number 14 at the end, because that time it was a internet issue. Okay. So, I think it is clear to everybody. Okay, let me show the number 14 also right now. Okay, so number 14, it was a very easy question. It said that in a particular human DNA, it has been observed that adenine is present in 30%. So, what will be the percentage of cytosine? So, since adenine has 30% and adenine binds with the thymine in the DNA. So, what will happen if 30% adenine is present, the percentage of thymine will also be 30%. So, total adenine and thymine will take up to 60%. Now, remaining is the 40%, which is taken by the cytosine and the guanine, okay, and each of them will have the 20% of the DNA sample. So, I think number 14 question, who have the problem in number 14, it is now clear to you, and also the number 17 actually what we done, I think it is now clear. So, if there is no problem, I will okay fine. Now, if there is no problem, I will move forward and we will solve the problem number 18. So, it says that the position where the tRNA will bind with the ribosome depends on its number A, codon sequence, number B, intramolecular hydrogen bonding, number C, anticodon sequence, and number D, hairpin like structure. So, you have to identify the position where tRNA will bind with the ribosome. Is it a codon sequence, intramolecular hydrogen bonding, anticodon sequence, or hairpin like structure? So, are there any answers for the question? B, C, C. So, we have one B and two C. Okay, let us check out the answers. Okay, so the answer is, correct answer is number C, anticodon sequence. So, this is the tRNA. Okay. So, this tRNA and this is the mRNA. So, the mRNA, it has the codons, which I have told you earlier. So, like this RNA has the codon, and the tRNA, it has 3 loops. Okay. So, one loop, it has one is the 3' region, which is the amino acid attachment site. Okay. Now, the first loop, it is called T loop, the second loop, it is called the anticodon loop, and the third one is called the D loop. So, in this anticodon loop, there is a anticodon. So, this anticodon sequence means, so if the codon is like G, A and G, so the complementary complementary basis will be, for the guanine it will be cytosine, for the adenine it will be uracil, since this is the RNA, and then for the guanine it will be cytosine. So, GAG, for it this codon, the anticodon is CUC, and according to this anticodon, the tRNA will bind the ribosome depending on this anticodon. Okay, and depending on this codon, the amino acid will be attached here. So, the GAG, the codon, it is actually with the amino acid for which it is codes for, it will be attached here. Okay, and further the reaction will proceed. Okay, so quickly I will move toward the next problem. I think it is clear, and let me check. Okay, yeah, so C was the correct answer. So, now I will move toward the problem number 19. So, it says that which of the following statement regarding RNA is false. Number A, rRNA acts as a catalyst to make the peptide bond. Number B, the amino acid sequence of the proteins depend on the base sequence of the mRNA. Number C, RNA polymerase 3 synthesizes mRNA. And number D, RNA polymerase 1 synthesizes the RNA. Now, you have to say which of the following statement regarding the RNA is false. Read each and every statement carefully and answer this, which of the following statement about the RNA is false. So, is there any answers for this question? Yeah, codon, anticodon, stop codon all are different from each other. Okay, so codon is basically on the mRNA, where the codon is basically each one codon is for responsible for adding one amino acid. Okay, stop codons is like the codons which do not incorporate any amino acid, and anticodon is the sequence of the bases in the tRNA based on which the amino acid will bind. Okay, so these all of these are different from each other. Okay, now coming to the next problem, number of 19. Okay, so the correct answer is number C, RNA polymerase 3 synthesizes mRNA. This statement is false. So, there are three kind of RNA polymerase enzyme, 1, 2 and 3. So, this is the comparison between the three enzymes. So, RNA polymerase 1 is that only transcribes the ribosomal RNA, but not 5S rRNA. RNA polymerase 2, it is the central enzyme that catalyzes DNA directed mRNA synthesis during the transcription proton coding genes. And RNA polymerase 3, this RNA polymerase that transcribes small untranslated RNA such as tRNA. Okay. So, RNA polymerase 3 does not synthesize mRNA, it actually synthesizes the tRNA. Okay. So, the first one, it transcribes rRNA genes. The second one is transcripts mRNA, miRNA, snRNA and snORNA genes, and the last one they transcripts tRNA and 5S rRNA genes. The first one they resides in the nucleus, the second one it resides in the nucleoplasm, and the third one it resides in the nucleoplasm. The first one, this transcripts pre-rRNA at almost 200 copies. The second one is transcripts around 25,000 genes, and the third one it transcripts 30 to 50 genes at a variable copy numbers. So, the first one they contain the same two non-identical alpha like subunits, and the second one it has two copies of a different alpha like subunit, and the third one it contains the same two non-identical alpha like subunit. And the first one it is insensitive to alpha amanitin, and the second one it is sensitive to 1 microgram per ml alpha amanitin, and the third one is sensitive to 10 microgram per ml of alpha amanitin. So, this is a kind of inhibitor kind of thing. So, these are the comparison of this three RNA. So, you do not need to memorize everything. Okay, just remember the first one, RNA polymerase 1, it synthesizes the rRNA. Okay, RNA polymerase 2, it synthesizes the mRNA, and RNA polymerase 3, it synthesizes the tRNA. So, remembering this three thing, it is enough for you. So, you do not need to memorize everything about this RNA polymerase enzyme, but which enzyme is responsible for synthesizing which RNA, it is important. Okay. Now, I will move toward the last question of today's session. So, question number 20, it says that which of the following agent does not have any effects of its own, and the options are number A, agonist, number B, antagonist, number C, partial agonist, and number D, inverse agonist. Which of the following agent does not have any effect of its own? So, try to answer this. Okay, we have some answers like answers A and answers B. Okay, for there is one question like which RNA polymer is involved in HIV disease. So, I do not exactly know it in particularly. So, I will just come to you with this problem and the next day. So, as you know that HIV is like human immunodeficiency virus. So, which actually what happens like the reverse transcriptase it is AIDS, which is the acute immune. So, the reverse transcriptase this enzyme is affected. So, I will just let you know this question, answer of this question in the next day session. Okay, I have to look at it. Okay, so we have some answers like A, D, B, C, and we have very versatile answers for the last one. Okay, so let's check out the answer. So answer will be B, antagonists. Okay, so it is defined as a macromolecule or binding site located on the surface or inside the effector cell serves to recognize with no other function. So, the following terms are used for the describing drug receptor interaction. Okay. So, agonist, it is an agent which activates the receptor to produce an effective similar to that of the physiological signal molecule. Inverse agonist, it is an agent that activates a receptor to produce an effect in the opposite direction of that of the agonist. Antagonist, it is an agent which prevents the action of an agonist or an on a receptor or the subsequent response, but does not have any effect of its own. And partial agonist, it is an agent which activates the receptor to produce submaximal effect, but antagonizes the action of the full agonist. And there is a ligand, which is any molecule which attaches selectively to particular receptors or sites. The term only indicates affinity or ability to bind without regard to functional change. Like agonists and competitive agonists are both ligands of same receptor. So, the antagonist, it is an agent which prevents the action of the agonist or the receptor or in subsequent response, but does not have any effects of its own. Okay. And just remember what are the meaning of the everything, like what is agonist, which activates the receptor to produce a similar physiological signal. Inverse agonist is the which actually alters or opposite the effect of the agonist, and antagonist does not have any of its action of its own, but it prevents the agonist or receptor. And inverse agonist, and there is a partial agonist which is activates the receptor to produce submaximal effect, but antagonizes the action of a full agonist. Okay. So, this is all the terms which is meaning. So, that was it for today. So, it was your week 3 details of the some questions which we discussed today was related to your week 3 course content. Few were from your previous year lecture, few questions were new, and most of you have answered almost all the questions very commendably, which is very good. So, if you have any doubt regarding any question at this point, please write me in the chat box. And anyway, there was some internet disruption. So, for that I will share this PPT and okay. The meaning of the partial agonist, antagonizing full agonist means the it will not actually have let the agonist to have its full value, means it will antagonize, means it will not let the agonist to show to have its effect or to produce it effect to a certain range, but it will not let the agonist to show its value to the I mean the full value of the agonist. Okay. The effect the agonist produce, the full effect it will not be produced by the partial agonist, it will be to a certain amount. Okay. Okay, so actually this so next week which portion will be covered? So next week we will cover your week 4. So this was for your week 3, and next week we will cover the week 4 lecture material. And for the thing like where the recorded lecture and the PowerPoint will be available, it is actually will be available to you by the NPTEL website. Okay. So in the SWAM website, I think there should be should be uploaded soon, the recorded lectures and also the PPTs. Okay. And you can guys also can raise the query about it in the forum also, like when it will be uploaded, because we actually do not know when it will be uploaded in the website. We actually send it weekly we update this lecture videos and slide in the to the NPTEL people, and we every week we do it after the class, but the sharing by them it will be only done by it. Okay, I will let you know the next class. Okay. And I will also raise the query about when it will be shared, and I will ask them to share it to you as early as possible. Okay. And if you have any other query, I will share my email ID to you. Okay. So, this is my email ID. So, if you have any doubt regarding this week 3 or about today's class or anything about the slides, so you can just reach me through the email. I will try to answer your queries, okay. And anyway, and these things all will be shared to you soon, and this type of class we will have each week, okay. So, the next from every week from Saturday from 6 p.m. to 8 p.m. So, we have these classes, and for next day we will have this classes on the next Saturday at the same time. We will cover the week 4 course material, and today if you have any doubt till now, if you have any query, you can just tell me in the chat box, okay. If you understood the things which we covered, did you like the class, everything about it, you just feel free to share, and if you want to more to be covered and anything. Okay, thank you all so much for joining the class, and I will expect you guys will join the class every week, so that we can just discuss this course and learn the course more better, okay. Yeah, thank you so much. I will share this to the website, but I don't know when they will share it on their website, but I will ask the NPTEL site to share it in their SWAM portal as soon as possible, okay, so that you guys can check it out from there. Okay, thank you so much. I also like that you guys interacted so much, because without any interaction, this kind of the classes, there is no meaning. So, every day try to join the classes and try to interact, try to answer the queries. It will be beneficial to both you and both to me also. Okay, so now I will just close today's meeting, and thank you all for joining, and we will meet next week. Thank you.